Alrighty. How you doing, students? Hopefully everybody's having a good day. So today what I'm going to do is I'm going to finish up the rest of the properties of exponents for you all. I will be doing 4 properties. I think it's 4 properties. And then you guys will be answering questions along the way. These problems are coming out of your course workbook. So hopefully you guys have them. If not, you can download the course workbook through Math Nation, and that is through your class link. So you have to log in through your student account on Osceola ClassLink, and then scroll down, find the Math Nation app, and once you click on section 1, right up under that video, it should be a link to click on to download the PDF. Okay, and these are where the problems are coming from. And so we're doing section 1, topic 2, and again we're going over the rest of the properties that I showed you guys from Friday. Okay. So let's go ahead and start it off. So we says here, it says, let's examine how to raise exponents to a power. So for instance, we have 5 to the third, and that's been raised to the second power. Now, if we look at it, right, if we use our, I think that is our product property, right? If we look at our product property, this is the same thing as saying, let me erase that, sorry. This is the same thing as saying, man, why my threes aren't doing good? Okay, here we go. It's the same thing as saying 5 to the third times 5 to the third, right? And if we use the property that we know about, which is the property of the product property, we know that we have a 5 here and a 5 here. And since they are the same base, we just add the exponents, right? So this just becomes 5 to the 6th power. Now, let's say, for instance, it was 5 to the third power raised to the 7th power. Well, then you would do 5 to the third times 5 to the third times 5 to the third times, and you have to keep going on until you get to 7 of them. What if it was 5 to the third raised to the 14th power? Then you have to do 5 to the third multiplied by itself 14 times. A shortcut way, though, is instead of just applying the product property, is that we could have just really just multiplied the two exponents. All right. So another way is that if you was to have just did 5 to the third squared, you just look at the two exponents since they're right next to each other, you just multiply them. So this just becomes 5 to the 6. Okay. And so that's the shortcut way that we do it. Now, not all the time are you going to have numbers. Sometimes you may have variables too as well. So let's look at the next one. All right. So we got 4 times x to the third. Now, x is just a variable, and is a variable that is in place of a number. All right. So what we're going to do is we're going to take this 3 and we're going to distribute it to both the 4 and the x. All right. So this is going to become a 4 to the third power times x to the third power. All right. So since the 4 is being raised to the third power and the x is being raised to the third power, we got to determine, are we finished with our actual problem? Well, since 4 is a number, we can actually continue to do that. Or we can actually continue to multiply that out. Okay. So you're going to do 4 times 4, and then that answer times 4. Okay. And so you should get 64. Right. Again, all you did was do 4 times 4, and then that answer times 4. So basically 4 times 4 is 16. 16 times 4 is 64. All right. X to the third, since it's a variable, you just write x to the third because you can't solve that one out. And once you do that, you are done. All right. And so what we did is that we just examined what happens when you raise an exponent to an exponent, or when you raise a power to an exponent, when you raise a power to a power. All right. Hence, we call this rule the power of power property. Okay. And what this states is that anytime that you have two terms that are being multiplied to each other, okay, so they have to be multiplied to each other. Say you had a times n, and all this was raised to the b, and this should just be a to the b times n to the b. Okay. I think in your book it has it a different way. I think a, b are together. So I think in your book it says if you multiply a times b raised to the n, is that what it is? Oh, they just have just a to the m raised to what? I'm gonna just say, let's say you had, oh, no, that makes sense. So if you had a to the m and that was raised to the n, then what this would be is that this would just be a to the m times n. That's all. Okay. All right, moving on. Let's examine when we have a product that is raised to a power. So a product is when you take two terms, you multiply them together. So now we're going to look at what happens if we have two terms. Sometimes it could be 3, 4, 5 terms. But I don't want to stress you out too much. I just want to give you guys just a little bit, and you guys can take it from there and be able to process and progress further along. So let's say we had two numbers that were being multiplied to each other, such as 2 and 3. Okay. Now let's do it one way, and then I want to show you a different way too as well. You get the same answer, right? So if we had 2 times 3, well, we know that we can actually do those numbers. 2 times 3 is actually 3. I'm sorry, 2 times 3 is actually 6. And so you still have that on the inside, and then you can square it, okay? So then 6 squared is just 6 times 6, which is just 36. All right? Now, let's look at it a different way. Let me just move this down here. That's all. All right, so let's look at it different. Let's say we distribute this power of 2 to both the 2 and the 3. Oh, this is just like what I did just, I'm sorry, students. This is supposed to be the power of a product property, but I think I did this actual example in the last one. So the last one was just supposed to be just power property. So you wasn't supposed to see this last one. That's 4 times x to the third. I'm sorry about that, but we're going to continue on with it. It's supposed to go here, which is right here. I'm sorry. But anyway, let's go back to this. So let's say you distribute that power to both the 2 and the 3. All right. So I stick with the black. I stick with it. So let's say, so if that was the case, this would just be 2 squared times 3 squared. Ooh, that's a bad 2. Okay. And so with that, what you do is that you're going to have to do the exponents. Okay. So 2 squared is actually 4, and 3 squared is 9. It was 4 times 9, 36. So still the same answer that we had, right? So we still have the same answer that we had from both ways. And the reason why I wanted to show you that, and this is what I meant to tell you in the other problem that was supposed to be here. Sorry about that again. But the reason why I did that is because there's not going to be all the time where you can multiply two numbers together or three numbers together. Sometimes you're going to have a number and a variable, all right? And so when you have a number and a variable, or when you have two different variables and they're being together as multiplication, and the whole thing is being raised to a power, you're just going to distribute that power to each of the terms, okay? So we're going to have 4 times x to the third. So 4 is a constant number. X is a variable. We can't, when we multiply, we don't get a number. We actually just get 4x, but we still have them both being raised to the third power. So since they're both being raised to the third power, we're going to distribute that 3 or that power of 3 to both of the terms. So this just becomes 4 to the third power times x to the third power. Okay. And if you still want to write the parentheses, you can, but you don't necessarily need to. But all right, I'm just not to confuse you because we didn't do really anything yet. Oh, well, like I said, yeah, you can take them out if you want to because you already distribute that power of 3 too. Matter of fact, we'll do that. We'll take out these. Okay, so we already distribute our power. So now we have to look at both of the terms. 4 to the third is a number. So we can multiply that out. So again, 4 times 4 times 4, that's 64. X to the third is just going to be x to the third. Okay. And so that's our answer for that one. And what do we call this property? We call this property a power of product property. Okay. A power of product property. So when you have two numbers that are being multiplied to each other, so let's say you had a times b, and a times b was raised to the n. If they're two different numbers, or if you have a number and a variable, then what you're going to do is you're just going to distribute this power to both of the terms inside of the parentheses. So this is just going to be a to the n times b to the n. That's all. Okay. So that's what the power of property states. Right. Okay, moving along. Let's explore when a quotient is raised to an exponent. All right. Now, the problem that you guys have in your book may be a little bit different. I just wanted to show you guys two different ways that this can be solved. So, the first way is that we have 20 divided by 4, the whole thing being raised to the second power. First thing I always ask my students is, can the numbers be simplified inside of the parentheses? So, can 20 be divided by 4? Okay. Or you want to ask yourself, can 4 go into 20? Or you may want to ask yourself, what times 4 gives you 20? Okay. So in that case, 20 divided by 4 will be 5. So this is just going to be 5 squared. Okay. And 5 squared is not 5 times 2, but it's 5 times 5 because you're multiplying 5 by itself 2 times. And this is going to be 25. All right. Let's look at a different way though. So let's say we took this 2 and we distributed the same way we distributed with the power of a product property. Let's try to distribute now when we are dividing two numbers and you have a quotient. Okay. So let's say we had distributed 2 and this becomes 20 squared over 4 squared. Okay. 20 squared over 4 squared. All right. So first off, what is 20 squared? Okay. Well, it's 20 times 20. All right. Well, we know that 2 times 2 is 4. And since we are multiplying 20, that means you got 2 zeros. Or you just use your calculator. You probably would have had 400. That is correct. Now, what is 4 squared? Okay. Well, 4 squared is 16. Now, you may not know off the top of your hand what is 400 divided by 16. So go ahead and take a break and go ahead and calculate what is 400 divided by 16 and see what you get. And you should have gotten 25. Okay. So when we look at a problem like this, we can see that if we cannot divide two terms that where you have a numerator and you have a denominator and it's not divisible, but you're raising both of them to a power, you can just distribute that power to both the numerator and to the denominator too as well. Hence, let's try not number, but let's try this example down here at the bottom. So can 6 be divided by y? No, it can't because y is a variable. But they're both being raised to a power of 3. So what do? We just distribute that power of 3 to both the 6 and to the y. Right? So this becomes 6 to the third power times y to the third power. Right? Sorry about that. Somebody send me a text. So, all right. So, can 6, since 6 is a number, okay, we're going to go ahead on and multiply it by itself 3 times. So 6 times 6 is 36. And 36 times 6 is 216. Okay. So remember not to make that mistake to multiply 2 and 3 to get 18. Most students do that. But remember, it is 6 times 6 times 6. Right? And y to the third power stays as y to the third power because y is a variable. Okay. Any questions at all from anybody? No. Well, if you had a question, it's not like I can answer it. I may be corny, but I crack myself up sometimes. And so this property is called power over quotient property, right? And so what this states is that if you had A divided by B, let me draw better A than that. If you had A divided by B raised to the n, then it just becomes A to the n divided by B to the n, okay? All right. So I'm gonna give you guys, so that was all of the properties that we did. So you guys, if you want to, you can pause the video now, and then you can kind of review it. You can play the video back to go over anything you want to do. But I do have a couple more questions I want you guys to try out. Okay. You're going to use your properties of exponents to prove if these equations are true. Okay. But if you're not ready now, like I said, pause the video or stop the video. Take a minute to digest what you guys just wrote down. Play the video back if you need to, and then let's progress on. Determine if the following equations are true or false. Justify your answers. Okay. So we have 3 to the fourth power times 3 to the fourth power equals 3 to the ninth power divided by 3 to the second power. Okay. So if we look at our left-hand side, 3 to the third power times 3 to the fourth power, what do you think property that is? Or what property do you think that is that they are displaying on the left-hand side? Correct. That's the product property. What property do you think that they're displaying on the right-hand side? Correct. That is the quotient property. Okay. So look at your properties and then let's move forward from there and see how you do them. And hopefully you know that if you look at the left-hand side, since the base is 3 and both of them have 3's, we're just going to add the exponents. So the left-hand side is 3 to the 7th power. Okay. Or we taking it step by step. We know that the product property states that we add the exponents, this becomes 3 raised to the 3 plus 4. Okay. Looking on the right-hand side, this is 3 to the ninth power divided by 3 to the second power. This is a quotient property. So when you have two bases that are the same and they're being and they're being divided, then you subtract the exponent. So this is the same thing as saying 3 to the ninth power minus 2. And so what is 3 to the fourth power? Well, what is 3 plus 4? So this is going to be 3 to the 7th. And what is 9 minus 2? And that's also 3 to the 7th. So this equation is true. Okay. This does work out. And good job if you worked it out by yourself. Okay. So you guys, this question right here. This is the final question for today, and you guys are going to be able to answer the question: true or false? Do these two sides equal each other? Be careful. Understand how to use your properties of exponents. I know it may seem kind of complex, but just try them out. Okay. Matter of fact, I'm going to start you guys off. I'm helping you guys out with the left hand side at least. Okay, or the right. I'll do the right hand side for you. Okay. So we notice over here that we have this parentheses. And inside the parentheses, you have a number 4 raised to the 6 divided by 5 raised to the -1. But all of that has been raised to the -1. Okay. So we cannot have any negative exponents. So what happens that anytime that we have negative exponents, we flip the actual we flip the expression that is inside of it, inside of the property, but we don't change any of the exponents that are directly inside. Okay, we're just flipping the actual fraction itself. So on the right hand side, you're still going to have, I'm writing in black, I'm sorry, erase this black. Okay, so this is still going to be 5 to the 4th power times 5 to the 0. There's a property for that. Times 5 to the -1 over 4 to the 6. And now this has been raised to the 1st power. Okay. That's how much I can give you. You have to do the rest. Hopefully you understand where to go from here. All right. So I'll do another video. And this video will be on fractions, and this will be to get you guys prepared for Monday. Okay. All righty.